another inference, a critical inference from IIT. One is essentially that, AI, if implemented the way it is, and for the foreseeable future, is not conscious at all, even though it may do everything we do. Another one, again, something that is very much against the grain of what people usually think, is that if IIT is true, then we do have true free will. That it is us who have alternatives, who can evaluate them and decide, and it's true free will. We discussed this at some length during the summer school. We will not here. There is a paper on that, but I just want to throw it there because, again, it's one of those things that in current neuroscience and cognitive neuroscience is considered to be impossible. Every smart neuroscientist knows that, hey, you're going to do whatever your brain does. Whatever determines what your brain does is what is going to explain what you do. And you are a passenger on this train who feels and thinks and has the illusion that they are deciding, but you really are not. It's your brain doing that for you. Or it's a convenient social figment so that we can sort of, make sure that, yes, we can talk about these things, but they are not really true. IIT says, no, it is fundamentally true. It's you and not your neurons when it comes to free will. So just go there, have a look at the paper, and it all has to do not with determinism versus indeterminism. It has to do with what truly exists, which is consciousness, and only what exists can cause. This can also be addressed through the tools of IIT. We published, with Larissa Bantakis a few years ago and Billy Marshall, a paper on actual causation that actually allows you to, in principle, use the same postulates to ask what caused what. That can be applied to the question of free will to yield to that conclusion. So more generally, everything that truly exists, questions, answers, problems and solutions, self, values, beliefs, thoughts and feelings, everything, including nausea, everything is a shape in the mind, so to speak, is a cosmetic structure. And that, again, has obvious ontological implications. And we are going to figure out this cosmetic structure. It's a long, long process, but that is the main claim. So never look at the subset again, hopefully, with the same eyes. Always try to unfold it. So I will end by, repeating that slide we saw before, and maybe with that triggering questions to make sure that at least the message, whether you agree with it or not, is phenomenality and function are radically different. They tend to go together with us. We can't do anything if we're not conscious, basically. But they can be dissociated. You heard that. And merely having experience, even with a blank screen, is immensely rich. And all the meaning, that's another whole set of things, all the meaning in the world is only the meaning that's in the mind. And that meaning is extraordinary, even for pure space or just the flow of time or any composition thereabout. Okay. So these are some of the key messages here. And I think they're particularly urgent at a time in which we are facing a world where not only function dominates, but we're also completely entranced by it. That is, we are attached to these functional things that answer questions for us, et cetera, all the time. And we tend to forget, or we feel a need for that, we feel alienated, that what matters is what exists, and what exists is consciousness, and that is being, okay? And maybe appreciate that a bit more, and put the two things as they properly deserve on the balance of what exists. Okay, so I'll end here, and let's hear questions.
No, it works. Yeah, first of all, thank you very much for the interesting talk and recap of what's currently happening. So I have a question about the AI system part of IIT. So it appears to me that in IIT 3.0's, AI systems could be conscious, computers could be conscious, because you could basically, you run through the possible grains, spatial grains, and the algorithm could pick out those grains that corresponds to the functional elements of the thing you're simulating. Like say you're simulating a brain, and you could pick out those grains that corresponds to the elements of the simulation. But then in 4.0, you added a new notion, a new piece to IIT, like the piece that, how we determine maximum grain. What are like possible units that we're allowed to consider? And it appears to me that this piece was added exactly to make sure that AI systems are not conscious. And so I wanted to ask this as a question. More generally, I'd like to ask, like, so what I struggle with in understanding for the 4.0 version is, like, it seems there are lots of changes that are not directly coming from the axioms, but there seems to be an additional principle that you invoke, and maybe you could speak to that, or maybe I misunderstood.
Yeah, I wish I had realized that I could detach this from the stand when I didn't have to hunch like this for the past. So I'll answer the first part and leave the second part to Giulio, I think. In fact, it's actually almost the opposite. So in 3.0, it was the same story. The computer was not conscious. We actually did all of this work originally in 3.0.
So maybe I should clarify. I know that you said it, but I think the statement in 3.0 is not correct if you look at the formulas.
So it was actually a lot easier to prove in 3.0 than it was in 4.0. And in 4.0, when we made these changes that you referred to about coarse graining and macro micro, it actually made things substantially more difficult to show, which they, still ultimately ended up being the same story. But that was, a sad story of a lot of work that ended up getting basically redone, reapplied in 4.0. But yeah, so actually, no, it's actually sort of the opposite. As for the pieces about the new inclusions that don't come from the axioms and the postulates, are there specific things that you had in mind?
Yeah, so it's, for example, this is the major thing I have in mind. Then you determine which units you get to consider. But I think there's similar changes in other places.
Do you want to answer that part?
Sure. Well, first I want to reinforce what Graham said, because indeed the computer conscience paper, as we call it, has been frozen for what, 5 years now? Yeah, 5 years. So there is a painful personal story behind all of that, and involving also Billy. So it was basically there, the message is the same, but because we have been working hard on developing 4.0 to try to address some of the known shortcomings of 3.0 in terms of translating the axiom into postulates, it's my responsibility that the paper didn't go out yet, because we knew that there would be a more consistent version. And so it turns out that with a more consistent version, it was harder to prove some points. The general message is absolutely the same. So quite the opposite of, oh, let's put in a little fix to make sure computers are not conscious. This is not the stance we take. We start from conscious and follows whatever it is that computers are not, and that there is free will, or it could have been otherwise. It's not a fix. In fact, the process and the reason why it has been hard, and Masafumi was reminding me of long walks talking about 3 binary units a long time ago, is that what is most difficult is the formulation of these principles existing taken from phenomenology, those 5, in the appropriate and unique mathematical formulation. And I think we made great progress there. And I'll give one example because I think it's quite relevant here in the context of structure. The example is relations. Okay, so we worked for a very long time, and one person worked a lot on that is Andrew Hound, who is not here right now in the co-author of the space paper. We worked for a long time to fix something that we knew from the very beginning was not there yet. That is a way to define relations in an intrinsic way, in a way that was physical and therefore causal. And we wasn't there, but got to start somewhere, just like we started with the Kullback library divergence as a measure instead of getting to the appropriate final version. So it took a long time because almost every talk about structure and relationship, and not to mention relations in mathematics, is a talk about extrinsic things. This is related to that in the following way. This is a partial order. This is that, or this is close to that in on the number line, or whatever. Okay. Whereas here, we want to characterize the relations that truly exist, the one that compose our existence. And again, by the same principle, they must be causal, and they must follow the postulate. They must be causal power, irreducible, maximally reducible, and so on and so forth. So a lot of work went to that. Hopefully, we came up finally, and it was hard, with a satisfactory formulation, so that the relations are actually there. You can unfold them from the subset, just like distinctions, and they are both causal. They both have a value existence phi associated with them. And so that was a long sludge towards 4.0 that froze the computer conscious paper for a long time. So I want to insist again, we are not making up a structure that looks interesting, maybe mathematically, and saying maybe this corresponds to consciousness. Is consciousness the way it is? Everything has to follow from there. The difficult thing is the proper and unique mathematical translation. So let's see if there's some other question that maybe brings up a similar point. Yes.
Thank you. Yeah, thank you for the very information-rich talk. I wanted to come back to like a general thing, but also a specific thing about the space section. So the specific thing is, in one of the slides you mentioned that we must experience countless spots in order to experience this kind of space. And they must relate in the following way, and then came the relevant formulations. Now I'm wondering, that makes mathematical sense to me, but I'm wondering to what degree that does not impose a mathematical structure onto consciousness that might not be there. Because if you think about psychophysics, right, we know that there are regions where we just cannot tell two points apart, right? I'm also thinking that if you're relating this to those cause-effect structures, I'm wondering, should we then also think that there are these kind of infinite, or, you know, as you said, countless cause-effect structures that we can associate with each of these points that then becomes brought together? So this is just a question about the space. The more general question is, how can we ensure in the general research framework that we refrain from imposing structures on phenomenology, you know, without making sure that they're actually there, right? So thank you very much.
Sure, thank you. Thanks for the question. So I will start answering the part of the question that I understood, and maybe somebody else can chime in. So to me, it's very important to focus on the attempt to characterize phenomenology first, and then see how good that is, and then see how we can account for the phenomenology in terms of cause-effect structures, or in general, anything that is an explanation that is more objective, quantitative, etc. So in the case of space, it sounds counterintuitive at the beginning to think it is structure, but to me, one compelling example, and this is just like an example that I find interesting, is if we want to explain in full some contents of experience, for instance, if I want to talk about taste, I really have to explain sweetness and bitterness and these kind of things, right? And if I have to explain my visual experience in full, I will have to characterize color. I will have to characterize the fact that I see shapes, but I will also have to characterize the fact that even when there's nothing on the screen, somehow it feels extended, right? And this is not true for taste. There's no such thing as, you know, one taste being to the left or included in the other, or to the top or close or far. Maybe if I compare different tastes, yes, but there's no extendedness in taste, and maybe in olfaction too. So this is just to the point that I don't think it's counterintuitive at all we're not imposing a mathematical structure on the phenomenological characterization of the extendedness of space. I think that derives from a detailed description of what it is like to experience extendedness. Now, there's a second point that is very interesting that your question brings up, which is a little bit like a chicken and egg type of question. Did we experience space first and then come up with the idea of a mathematical space and topological space and set theory, etc.? Or are we just trying to impose set theory, rediscovering set theory in describing our experience of space? IIT claims it's the former. We actually experience extendedness, and that's why also space is very pervasive. And that's why we impose this idea of a topology and set theory on our understanding of the world, and even abstract concepts like mathematical sets, etc. So I hope this covers a little bit like the part where we are not imposing a mathematical structure, but actually it comes out of a phenomenological description of a feature of experience, which is extendedness. If anybody wants to add some.
Well, if I understood the second part of your question, I think to elaborate a little bit on what Matteo said, is primarily this. So yes, we're certainly not trying to impose a mathematical structure, but we do, as of course, starting with the axioms, and then for space and time, where we can, employ introspection to begin this dissection of what experience is like. Okay, of course, there is a phenomenological tradition, there is a microphenomenological tradition, and they all look at different things. But to some extent, of course, they're all talking about your own experience. And as I said, when I mentioned culpa and Titchener, for instance, you could try to dissect experience by isolating all the atoms, and that's probably not a good exercise. 20,000 according to one guy, 9,000 according to the other guy, and so on and so forth. But there are some fundamental things, and that's sort of where the choice is, where you can start. What are the properties that you cannot conceive an experience not having, which are really properties of existence? That's a key thing, okay? And then space and time, let's get started. It looks like you've got spots and they do this and that, and for time you've got moments, and a little bit more with object, but not much more. That part of phenomenological dissection is tentative. So it's not that, you know, we are 100% sure that that is the best way to capture the fundamental property of extendedness, leaving aside all the other properties like color and shape and so on. But it's a start. We made a lot of effort to try to find the fundamental ones from which the other ones in principle can be derived. But it could be wrong. The message though, and that's important, is you want to begin with the phenomenology. There is nothing else. What needs to be explained is consciousness, and we have, unlike the organoid probably, the ability to judge it. That's exactly what, you know, now and Masafumi are using, and of course psychophysicists have been using before, comparing, judging, and so on and so forth, on top of just experiencing things, okay, which allows us to do all these other things. But we're trying to get at the very basics, where then we can make a connection to the theory that follows purely from the way existence, you know, requires the substrate to unfold. So beyond that, I think we will trust phenomenology less and less and go the other way, say, if the unfolding of this substrate is like this, then we should be able to now probe phenomenology again and see whether these inferences from the unfolding of the substrate do fit with what people experience, and so on and so forth. So the scientific side, I think, will be, if things go well, very much on, you know, on the here's the substrate, here's the micromanipulation of the substrate, strengthening connection without changing activity, all the kind of things I mentioned, and see what difference it makes to phenomenology. And we'll refine that way our phenomenology in a different way than what poets or musicians do, but still refine it in a scientific. Okay.
I do a short follow-up. I just want to it's again me, sorry. Just a short follow-up. I find that a very revolutionary move to say you're coming full circle. You start from phenomenology, develop these axioms and theories, refine them. But then again, also in your talk, you came back to this idea of testing these by phenomenology. And I just want to say that I find this kind of very novel and very interesting, but also very intuitive that this comes from your theory. Could you say a little bit more about that?
I think you said it beautifully. Thank you. Okay.
In a follow-up to the morning Q&A on the exclusion axiom, I was wondering, so like if there was a macro consciousness to form in this room, like I would assume that would be lenient on our conscious behavior. So like as this macro consciousness forms and then we are no longer conscious as participants in this room, then like the macro consciousness would kind of also collapse back again. Just wondering if there's something that I misunderstand, or if like that's very actually something we can observe, like in nature, that organisms of certain sizes, where the integrated information of individual neurons and that of the entire nervous system are kind of on par, have this kind of collapse problem.
Okay, so if I understand, okay, there are a couple of things to say about it, and hopefully that will clarify a little bit the spirit if not the substance, because we don't really know. So yes, the exclusion forces the conclusion I mentioned before, that if you and I exist, and I suppose for yourself you do, and for myself I certainly do, then IIT says there is no collective consciousness at the same time. That's the claim. If we were to fuse, then there would be the collective consciousness, but not the individual. So we would disappear. Now, how do you fuse? Now, for all I've said, I don't see in any way as being a practical thing, because it really requires, we think, this dense physical lattice to be able to be an entity that exists a lot for itself. And so posterior cortex and part of central cortex have that extraordinary architecture that nothing else we know so far has. Okay, and so it would qualify, and that is testable. The place where, it's a thought experiment in principle is doable, where we could examine this, is the classic case of the split brain. So that's a fusion or, dissociation between two. Then there are psychiatric dissociation that are also interesting, but more difficult to study. But just to give you a sense, then the idea has always been that when you are one entity, so which presumably we are, there is one big main complex that straddles across, much of posterior cortex. If you cut the corpus callosum completely, or turns out, especially the posterior part, then the evidence suggests suddenly you have two consciousness. There are some issues about this, but that's the main result. And so a thought experiment, which however is a doable experiment in principle, is if we go through a cooling, say, or an activation of the corpus callosum progressively, such that we go from being one to being two, which we sort of know are the extreme points empirically, there should be a singular point, exactly the one at which the phi of the main complex, which is both, becomes smaller than the phi of the two separate hemispheres, or at least one of them, okay, and then the other automatically follows, where you go from being one to being two, which is a pretty big ontological change. Okay, and there are two of you. So this is actually something where we could test and just move around there. You should fuse and unfuse, something like that. Okay? So I hope it captures a little bit, what you were asking.
Is there a finite lexicon of ways in which you can build a cause-effect structure, as space and time seem to be very related in the way the distinctions relate to each other? You add a directness to time, which in space you have reflexivity. And I suspect the story for objects is similar, it's just hierarchical. Does that entail that there is a limit in how many ways you can build the cause-effect structures and the types of substrate that you can have for them?
I wish I had an answer to that. It's a intriguing conjecture. I would say that it's very tempting, and that's why you saw that research program, okay, to think that different kind of graphs, if you wish, of causal models, will unfold into different kinds of cause-effect structure. There's going to be a finite and possibly small number of types, okay, that then can be composed in various ways. And I asked this in the course of the summer school, I asked this question, okay, to mathematicians, because it is a mathematical question ultimately, whether it makes sense to categorize the kind of causal models into a few types that are possible, at least within the constraints of something like angular hardware also. So I think it's a big question, and one of the tantalizing answers to that question would be that as much as we wonder whether what it's like to be a bat, and if IIT is right, we should be able to say, well, it's mostly spatial and so on and so forth, with different local qualities because the kernels are different and so on and so forth. But it may even be that the kind of possible experiences may already be exhausted by us, largely, or radically different. There's an immense universe of possible kinds of experiences, not just different local kinds, okay, that are available if you really had the right substrate. So as a question, I don't know the answer to that, but it's a great one.
Hello, related to Robert's question, actually. Let's say the slide where you showed how the different properties of experience are mapped on the cause-effect structure. Let's say on the upper side there was space, and on the lower side there was time. Let's say
how they mapped them together to one cause-effect structure, that it seems like there was no overlap between this cause-effect structure, those mechanisms within the cause-effect structure. And let's say from my intrinsic perspective, it seems like also when I move my head, my experience of space feels flowing. So are they not connected in such a way that the space and time are interrelated in such a way that the grids form a sort of 3D structure where one state is passed onto another?
Thanks for the excellent question. So one clarification is that the reason why the two substructures here are separate from each other is that here we are building two systems, in this case, two substrates, one non-directed grid and one directed grid. They're just separate from each other. There is no connection between them, so they cannot possibly relate. Like we're really unfolding two separate systems. This is just for simplicity because we're treating them as systems, but there will be subsystems. In reality, it's exactly like you say. So not only there would be a time grid and a space grid would be part of the same system. There will be mechanisms that have relations, specified distinctions that have relations. So for instance, if you see a dot moving, of course, there would be some phenomenal distinctions that are characterizing the feeling of flow, for instance, the direction, the speed, the fact that the dot was here and now it's there, but also the fact that it is somewhere in space. So of course, there will be relations between time distinctions and space distinctions. But on top of that, even within, like we saw with the questions before, even within auditory experience per se, you would have many different sounds that are related to the time grid, in this case as local qualities, and they would have relations between themselves, just like you would have a lot of space grids, for instance, for your somatosensory space, bodily space, or visual space that are all in register with each other, and they do form relations within each other. So all these things really in the cause-effect structure of your experience are immensely, blended with each other. There's relations probably across every modality and every other modality. A lot of things are bound to space, and probably everything is bound to time, since you have a global experience of a present moment in which every content of every modality is experienced, right? So what you describe is really the full picture. Here we were simplifying based on the systems that we are actually unfolding. But yeah, thank you.
And thank you for the great talk. I'm a little bit maybe confused in the simulation scenario you mentioned. Of course, let's say we have a system, and then we can use some like a Turing machine to simulate it. And so the Turing machine maybe if we compute its causal effect structure, and it doesn't give too much fight. But let's like flip this slow story the other way around. Let's say we have a universal Turing machine first there, like any computer we have, and then we start to design to write a program that create a crazy interaction, a lot of elements. Even maybe we can say we can define more than a neuron and synapse we have. And that's the program. And we run that program with the Turing machine. And of course, with our current computational power, the progress is very, very, very slow. But within that program, it has a very complex causal effect structure. And how do you think about in this situation? Of course, it's very, very slow from our time scale, but for its intrinsic scale, it's still there.
Yeah, so there are a few parts to that question. The first thing, which I think is a good opportunity to clarify, is the Turing machine is an abstract thing. It doesn't exist physically. And I'm not saying you're saying it does, but that's the thing to really make clear. Because what IIT cares about is a physical system. You need something that is a physical instantiation and implementation of this thing, right? And when we get to, there's these wonderful theories that deal with computability and computation in the abstract. And things get quite tricky when we start to talk about physical instantiations of computation. It's often a very philosophically murky territory. So what we're dealing with here is the physical systems, right? So assuming for the rest of, for the next part of the question that by Turing machine, you're talking about the physical instantiations here. The idea here is, so first of all, the grain is whatever the intrinsic grain is that maximizes phi. And so if it turns out that this thing runs very slowly in the sense of clock time, it takes, very many updates or something, but that is the grain at which phi is maximized. Then IIT says that is the grain at which it supports the experience. And then things get a little bit more complicated because you have to think about, the thickness of like a perceptual moment, right? You have an experience of time. Well, that itself is a part of the experience. There's a whole separate question about how that maybe relates to the actual update grain that's underneath. I'm not sure if that's what you're getting at, but it's just something to point out. But ultimately, the idea here is that for this particular instantiation implementation of this machine, it doesn't matter what is being simulated. It doesn't matter if it is a human brain. It doesn't matter how long it takes. It's not going to be like anything to be this computer while it does that simulation. Does that make sense? Does that answer your question?
I think my point is more about like we theoretically can design, write a program that run for a very complex system, very, very complex. And theoretically, we can even like we can decide it's much more complicated than a brain, and that has a massive interaction. So theoretically, we can arbitrarily create a hi-fi at macro scale.
Well, so this is the thing. The program itself, the abstract program, there is no, phi is not defined on the space of programs, only on physical systems. You have to take that program, that algorithm, whatever it is, and you have to have some physical instantiation of that computation. And you can say, I want this symbol in my program to map to this physical macro state of the thing I'm simulating or something like that. But the idea of an abstract, like an algorithm having phi, it doesn't work in IIT.
But maybe the final question about this.
Okay.
But it's to me, it's you already assume there is a physical substrate, so that run this program. But the reality is we have everything we measured, and we have experience, and we don't know whether it's some kind of simulation underlying, and how do we eventually know what's the physical substrate?
So
it's totally not wrong for analogy.
Yeah. I'm not sure that I fully understand this question. Maybe I'll hand it to Giulio if he does, but so the existence of the physical world here, right, is a purely postulated thing because we're starting from phenomenology. Our experience, we know that exists. The existence of the physical world out there to begin with is the thing that we are not sure about. We accept it because it's the best regularity or best explanation for the regularities of our experience, right? But we don't know that it's there. So when we draw a substrate here, this is a model basically where we're saying, imagine you've gone in and you've operationally have some things that you can manipulate and observe, and you found that the states affect each other in these conditional ways, and it builds this model. So you find this TPM, and from that you draw basically the model that supports the computer, the various diagrams and the things. So it's not exactly the case here that we're starting from, we're never really starting from a substrate, if that makes sense. All right.
You wanna
I'm-
answer? Maybe there is one perhaps useful thing to add, which is we didn't talk about it here. We did a little bit at the summer school. When we go through the assumptions of IIT, we go through and say, for instance, IIT assumes realism, physicalism, and atomism. And realism is to assume that when we want to explain things, there are things that exist beyond ourselves, including all of you. Okay, so it's a reasonable assumption. And this is an old story in philosophy about solipsism. That is, in principle, it could be that each of us just exists as a mind having experiences, and everybody else is just a figment of my imagination, or my mind is a dream. And that's the only thing there is. Now, it's notoriously, you can't prove that solipsism is wrong. Okay? It's just, we like to say, a terrible hypothesis. It explains absolutely nothing. It doesn't explain regularities of the everyday kind, why things fall, why I close my eyes and open them, I see the same stuff. The singularity is very much the same. Silly idea that maybe what every one of us is experiencing, maybe all of us together, we are just the result of some simulation that is being run in some, other reality, etc., etc. You can say that. You might even say that it's impossible to prove that is wrong, but it actually explains nothing. In particular, it doesn't explain things why in the simulation, if I hit this particular place in your brain, you're gone. If I hit another place, you're not gone. If I warp connections in your visual cortex, space contracts, and an immense number of pieces of evidence that fit hopefully well with a theory like IIT that tries to explain these things from first principle, from consciousness itself, for which this gigantic simulation has absolutely nothing to say, because just like with solipsism, you can say anything you want. It's like this or it's like that, and there is no reason why it should be this way rather than that way.
Hi. My question has to do with sort of going off of that. Now, I'm a process ontology person, but I'm going to go ahead and stick with atomism for the purposes of this. The question is, so you're saying there has to be a physical substrate, and I absolutely comprehend that. Now, the question is, how are you determining that? Because at the very small scale, like at the, like picosecond or whatever they call it, I'm not interacting with you. I'm not interacting with very much of anything. It's just, this like a tiny space, right? And my physical body is interacting with the air, the local sort of area. If we think about the computer, right? It's not atoms, but it is electrons whizzing about, right? Being stored, but eventually moving to different places. So you could see how at a certain scale, it's very similar. It's physical in that way, and you can say that, okay, well, you know what? There's not a clear structure, but the structure can be distributed, right? It's it can be distributed in space, but also in time. And I think you can make a good argument for, well, you tell me your thoughts. Thank you.
Yeah, so this is basically the idea behind considering the macro brains, is pretty much exactly to consider this possibility of this distribution in space and time. And it is, I guess the simplest way to say it is just not the case, according to IIT, the fact that, so maybe I should try and answer this a different way. There is often this intuition that because I can go ahead and I can create sort of these mappings between what's going on in the computer, say between these electrons and where they are stored in this particular, register XYZ, and between this thing of interest, that because I can find a mapping, like the existence of the mapping must mean something about that is what the way that I should be thinking of the computer, like conceiving of what it's doing, of its computation or something. And in IIT, it's really different. There's sort of the way that you carve the substrate into these units, right? It doesn't get to be arbitrary. It doesn't get to be that just because I can go and I can chart over the course of a whole cycle of the simulation where everything is and map it to where it is, how it corresponds to the thing being simulated, that is what actually exists from its own perspective, that's not where the maximally reducible cause effect power of the substrate upon itself is. And so that is what we basically evaluate when we do this macro graining, when we consider all these possible distributions over space and time of the states of the elements. I don't know if that makes any sense.
No, it made a good amount of sense. I think what it goes down to is a sort of difference of perspectives, right? Because I would think in my own perspective that I'm not artificially creating a mapping between the process and the the computational thing. I would just say that that's what it is. But that's because I think of things as a sort of process ontology thing. And I would say at the very low level of like even us, you could say, well, you know what, the neuron's only doing this, this, and this, and this, right? So I guess the question is one of like, where do we scale? Why do we scale the way that we do? And why do we take certain sorts of structures to be prioritized over others when the structure at a different level of abstraction, whether it be smaller or larger, is the same? But I think it's just a difference of perspective.
I'm going to hand this to Giulio in a second because he's going to give you a much better answer than I could. But I will say one other thing is that, when you look at what is happening in the physical substrate, according to IIT, you have to consider everything that's going on, and what we would normally say is not less and not more, right? So when you, for instance, look at a computer and you create your mapping of states of the elements of the computer to states of the thing being simulated or something, often what you are doing is you are then ignoring the states of everything else that's going on in the computer, all the other units that are not computationally relevant at that point in time, and whereas when you have obtained your cause effect structure that you're trying to simulate from the brain, you've already basically accounted for that. And so when you look at a computer, you have to look not just at like the fact that it's doing there, sure, that is there in a sense, but there's also a lot of other stuff that is there in the computer that you cannot sort of like put your hand over and ignore when you're doing that. You have to consider not just the states that are important for that function, but everything else that's always happening at the same time. I'm going to hand it to Giuliano.
Well, the most important thing to say is that it is 501. And so from that point of view, we are going to, I think it's time we can continue this discussion. But I take the opportunity to say two things. One is sort of along the lines of what Graham was saying, which is perhaps not really what you were after. And that is that you can project any computation or grain that you might find relevant on the so-called physical world. And this is an old argument made by Hilary Putnam, who, initially sort of brought out functionalism and then killed it by this very much reasoning that, you can read any function into some microphysical events that might be happening. I think that's a little bit related to how Graham answered your question and saying instead in IIT, you need some principles, the postulates essentially of IIT, to tell you what you can do and what you cannot do. So the second thing I want to say is a little bit closer to you, but that's really for the reception, given that you come from process ontology, is that what IIT really brings initially to the game here is the properties of existence. What it takes for something to exist, as we know them intrinsically, is the only way you sort of know them. And then formulates them in this operational and finally mathematical way so we can check whether there's fault. So everything, it's about ontology indeed, okay? And the claim is that those 5 properties, apart from there is something that exists, okay, that's experience, that every experience is intrinsic, specific, unitary, definite, and structured. And from there, everything else follows, the accidental properties of the experience. That's what you go from. That's what we explain everything from in operational terms when you translate this definition operation. And notice, I didn't bring up process, dynamics, or anything like that, in characterizing what exists. Change may happen or not, and it's not an essential property of being. But of course, it happens, very important, and so on and so forth. But this is, for the discussion later, is precisely that. It's using essentially only what existence is like when it's actually there versus when it's not, which is when you're consciousness and when you're not. And translating what that is fundamentally into an operational principle with which we can check, first of all, on ourselves, whether that story, so the metaphysics that follow from the ontology, holds. Then it becomes a scientific metaphysics because you can test it and extrapolate from there. And ultimately, you actually extrapolate to physics in general, because it gives you this ideal version of a world where the unity between consciousness and the so-called physical world is actually achieved by taking consciousness as primary and inferring the properties of what actually exists based on that. Okay. Let's say thank especially now and Masafumi for organizing this. I'm very grateful that we had this opportunity, and I also especially look forward with whoever is interested in pursuing one thing that sort of should have come out, but it may be useful to mention at the end, the possibility of investigating phenomenology in this new way that they started the morning with, that is mapping the similarities among our experiences, their way sort of doable, project them onto the brain, and see whether we can have an intrinsic account for that, and these two things can inform each other. I think that is ripe for scientific investigation of a really novel kind. And it's the demonstration that you can treat phenomenology seriously and make it into a testable proposition. All right. Thank you, Ellen.